You've seen them, right? Driving down the highway, you see this whole field of giant wind turbines spinning, and you've probably wondered why 3 blades? I mean, it's so specific. Well, you're not the only one. It's a super common question, and the answer is actually a brilliant piece of engineering. So let's really get into this. I mean, why not 2 or 4? Or heck, why not just 1 blade? You'd think if you wanted more power, you'd add more blades, right? Or if you wanted to save money, you'd use fewer. It feels like there should be a simple, straightforward answer here. But you know what? There isn't one. The real reason we've landed on 3 blades is because it's the winner of this really complex battle between a bunch of different competing factors. So we're going to break down that whole puzzle piece by piece. And it all comes down to these 3 things. Performance. How much energy can you actually capture from the wind? Cost. How much does this thing cost to build, transport, and maintain? And finally, stability. How well does it hold up to all the crazy forces of nature? So let's start with the one that always matters most, cost. In pretty much any kind of engineering, simpler is almost always better. And it's definitely always cheaper. So it just makes sense that the starting point for any designer is to use as few blades as you can possibly get away with. And check this out. The costs really stack up in ways you might not expect. It's not just about using less material for the blades themselves. And remember, these things weigh dozens of tons each. It's also the logistics of hauling these massive parts down the highway and the time it takes to actually put them up. Fewer blades just makes every single one of those steps easier and cheaper. Okay, so if we take that logic all the way to its extreme, we get to the cheapest possible design you could imagine. A turbine with just a single blade. It would be the cheapest to make and the easiest to install. So why don't we see 1-bladed turbines everywhere? Well, this is where physics and stability come in and just completely crush the cost-saving party. Because it turns out that both 1 and 2 bladed designs have these fundamental deal-breaking flaws. Take that single blade concept. First, look at the hub. See that block opposite the blade? That is a massive counterweight. You actually have to add dead weight just to stop the turbine from shaking itself apart, which basically cancels out the money you saved. And it gets more embarrassing. A 1-bladed turbine is actually unable to self-start because the balance is so weird. It can't just catch the wind. You literally have to use a motor to spin it up, draining energy from the grid before it can even start making power. Once it is spinning, it fights the air. Wind is naturally faster higher up. So at the top of the arc, the blade feels massive thrust. At the bottom, barely any. It creates a constant, violent seesaw of force. Plus, every time that single blade swings past the tower, it hits the tower shadow. The tower blocks the wind for a split second, creating a rhythmic pressure drop, thwack, that hammers the bearings. So naturally, engineers thought, okay, let's just add a second blade. That should balance the weight and solve everything, right? Well, not quite. The 2-blade design creates a completely new, hidden problem called yaw instability. Think of an ice skater. When their arms are out, they spin slow. Arms in, they spin fast. A 2-blade turbine does the same thing. When the blades are horizontal, resistance is high. When vertical, resistance is low. As the turbine tries to turn to face the wind, this constantly changing resistance creates a nasty wobble called gyroscopic precession. It is a jerky, twisting force that fights the tower twice every rotation. Over time, that wobble causes structural fatigue. It creates stress cracks in the hub and tower, drastically shortening the machine's lifespan. And this brings us to the industry standard, the 3-blade design. The secret to its success is actually hidden in the number itself. Nature loves odd numbers. Look at the load distribution. With an even number of blades, you get stress spikes. But with 3 blades, it is smooth. When 1 blade is up, the other 2 are spread out down below. The forces cancel each other out, creating a perfectly balanced spin. So if 3 provides that stability, wouldn't 4 be even smoother? This is where we hit a hard economic wall. Check out the calculation. If you add a 4th blade, your manufacturing and transport costs skyrocket by about 33%. But here is the kicker: your power output only goes up by a tiny 2%. You are paying a premium price for basically 0 extra reward. The math just doesn't work. Plus, adding that 4th blade actually hurts your aerodynamics. The 3-blade design hits the absolute efficiency sweet spot. The 4-blade design actually loses efficiency at high speeds because the blades are too close together, they create drag. And there is one more factor we rarely think about: biology. To capture the same energy, a 2-blade turbine has to spin much, much faster than a 3-blade one. That high speed creates a phenomenon called motion smear. To a raptor or an eagle, a fast spinning 2-blade turbine becomes invisible, a ghost in the air. But because 3-blade turbines have more torque, they can spin slower. This makes them easier for birds to see and significantly quieter for humans living nearby. So, for the last 40 years, three blades has been the Goldilocks choice. It's not the cheapest, it's not the most stable, but it is the perfect compromise where physics, economics, and biology finally agree. But will it stay this way forever? Look at how our materials are changing. We are moving from heavy fiberglass to ultra-light carbon fiber weaves. As blades get lighter, the old rules about weight are starting to fade. And then there is the new frontier, offshore wind. Out in the deep ocean, nobody cares about the noise, and birds are far less common. Because installation costs at sea are so high, engineers are actually looking back at the two-blade design. So, while the three-blade king rules the land, the future of the ocean might just belong to the rebellious two-blade giants. It seems the engineering war isn't over just yet.